Hello, welcome to the second day of this bootcamp. Let me just share my screen. Okay. So this is the second day. We will be discussing OpenCV. And OpenCV is a library for image processing or computer vision. And it's usually used for like low-level image processing. You want to detect color, for example, you want to draw something on the image and so on. Not really the heavy like data-based stuff like machine learning, but it's very useful. And even if you use machine learning or something else, you will probably input the image using OpenCV. So yeah, it's very useful. And one thing I want to say before we start actually coding uh, is the coordinate system for OpenCV starts from the top left corner of an image. So it's not the normal coordinate system where y is going upward, y is going down. So if the y value increases, we're going down.
Hello.
And hello? Yeah. Yes, I can hear you. Do you want to ask any question? Okay. So let's directly go to the coding part. I assume that you've all installed already OpenCV. So this is the folder that I've given to you guys. And let's just create another file and let's call it OpenCV. Okay. So the first thing that we're gonna do when we create this file is import OpenCV. And the way we do this is we just type import CV2. So this is the first thing that you have to do. Import the library itself. And let's say the first thing we need to do is import an image and then display it. Okay. So let's create a variable. Let's call it image. And then we're gonna read. So cv2.read. It's called read image or imread, or it's like image read, short for image read. Okay. And then we're gonna pass the image itself, which is vector jpg. Okay. This way we have the image inside this image variable. And in order to show this image, we will call a function called imShow, which is short for imShow. We need to provide the name of the window. So let's just say image, and then the image itself that we want to show. If we run this without adding the next line, it will show the image for like 1 millisecond, and then the code will exit, or less than even 1 millisecond. So we need to add something to wait. So it's called cv2 wait key. And then it takes the amount of time to wait, and we can just set it to 0 to make it like infinitely wait. Okay. Later we'll change this to 1 millisecond or something. It's in milliseconds. So yeah. But if we set it to 0, it will wait until we press any key on the keyboard. The function is wait key. So it's waiting for a keyboard press, and passing 0 will make it wait forever. Okay. So that's it. That's all we need to import an image or like read an image, then show the image. If we run this, we should get the image of like totally normal Will Smith. Okay. And then if you press anything on your keyboard, the image should close. So I'll give you like 2 minutes to try doing this. And if you have any questions, you can just ask in the chat or just open your mic. Okay. So the next thing we're gonna do is read a video, not just an image, and then we'll show each frame of the video. So let's just comment this for now. And first we need to create a capture object. So we'll say that cap is equal to cv2.video capture. So this is a video capture object that we'll use to capture the video. And then we have to pass the video itself, or we can pass numbers that if we pass numbers, it will use it to open the webcam of the laptop or any attached USB cameras. And if we type a specific file name, it will find this file and then play this file. So let's say we want to play cat.4. Okay. Then we need to create a while loop to check if the cap is open, if the capture is open, if is opened, if there's still a video, if it's open, then we'll do something. First thing we're gonna do is to get the actual frame. So the function we're using is cv2 dot is cap dot read. This is the capture that we define, which is using the scat video, and then reads one frame of this capture. Okay, and you can see that it returns two returns. It has two returns. One is the frame of the video, and the other one is just return whether it's successful or no. It's a Boolean, either true or false. Okay. And once we have the frame, we can just do the same. Can show this frame. Image show cat, and then show the frame. We also need to wait, use wait key, but this time we wait only for 1 millisecond. Because if we set it to 0, then each frame of the video will need to press the keyboard one time, so it goes to the next frame. If we press to 1, then wait for 1 millisecond and then continue the while loop. Okay? So this should be enough, but we need maybe something to break, because if you press something, it will not exit the while loop. So we need to add a condition to break. So let's say if we waited for a key and this key was equal to, we'll use an ORD function, which like returns the Unicode for a character, and usually they use the character Q. So we'll wait for a key for 1 millisecond. If this key is pressed and it's equal to Q, then we'll break from this while loop. Break is just exit, don't continue the while loop. Okay. So this should be enough to display the video of the cat, as you can see. And if I press Q, it exits the video. Okay. Any questions so far regarding this video module or the image module? Just loading the video and playing each frame.
I have a question about the CV2.
Okay.
How to import the CV2? Because when I try to write import CV2, it doesn't work with me.
It doesn't work?
How to import the CV2? What is the CV2 to be
CV2
specific?
is just OpenCV, the library that you install, which is OpenCV Python. If you say import CV2, then it should import this OpenCV Python library.
But the message I get that import CVT could not be resolved.
Import CVT could not be resolved. Then
Yes.
the library didn't install or failed to install. Did it say that you can try to install the library again and check if it says like requirement already satisfied? Okay.
To install the Python again?
No, not the Python, just the
Okay.
OpenCV library.
Is it supposed that we see like a cat video when we like run the Python code?
Yeah, for this one.
I tried to run it, but I got like this red message.
Oh, which should message? Can I repeat the while loop explanation? Yeah, sure. So this while loop is if the capture is open, if there are still frames in the video, then we'll continue to read. And the first thing we do is we read the frame. And there's also this return bool. It's a boolean. It says that yes, we were able to read a frame or not. So we can use this later to say maybe if return is false, then break also. And for each frame of this video, we're showing this frame using the image show function. And we're waiting for a key press for 1 millisecond after we show each frame. If there is a key press and this key press is Q is equal to Q, then we will break out of this while loop. We don't want to continue reading the frames and showing the frames for the video. Yeah, that's all. If you don't press Q, it will keep looping until there are no more frames, and then it will give an error. We can avoid this error by saying if return is equal to false, then also break. But for now, we don't really care if it gives an error after reading the video.
I tried to run the code, but nothing happens. Like there's no errors and there's not nothing.
You might be in the wrong folder maybe, or it can't find the cat MP4. Make sure you're in the same folder as the video. Maybe. Or sometimes Visual Studio Code itself might have the problem. So you can maybe go into your terminal here, then type, like manually type Python and then the name of the file, which is OpenCV.py. This also works. So try doing this method if the current method, like just pressing on play doesn't work. Use this for some. This is the same. The code that you send will just create a virtual environment and then install OpenCV Python inside this virtual environment, which is should be the best practice, but it's unnecessary. You could just pip install OpenCV Python directly. But yeah, should be okay if you want to also follow this method. Any more questions regarding this? Python can't open no such file or direct. Yeah, you might be in the wrong folder. It says that this doesn't exist. This OpenCV.py maybe doesn't exist inside the bootcamp folder. It might exist. Do you have this OpenCV folder? You need to maybe cd into this first. So what I'm saying is maybe you're here. You need to cd into OpenCV first, and then run Python OpenCV. cd is short for change directory. Library shouldn't be an issue. Including the library itself shouldn't be an issue. And it doesn't matter which the other images and videos that you want to import, should be fine. The library doesn't really care about the location of the file. But the thing is, if you're inside the previous file, if you're not inside the OpenCV, then you might need. If you're facing this issue, you can maybe say open folder and then go inside your folder and select the OpenCV folder. This way you make sure that it's only running stuff inside this file. Okay. Yeah, the code is working, no error, the video doesn't pop up. I think it's because of the location. I think if I do this and try to run this, yeah, this happens, right? It runs, but no errors, no video. You need to cd into the folder that you're in. Let's say it's OpenCV, and then run. Then it will run. Okay.
I did the open folder thing, then it just worked right now. I don't know how, but it just worked.
Okay, nice. I think it's just VS Code. Any other questions before we proceed? Okay. If there are no questions. Okay, the next thing that we might want to do is resize this. Currently, this image is very small, or this video is very small. So let's resize every frame so it's like visible. For example, it's equal to, we're assigning to the same frame, cv2.resize. And then the first thing we're passing is the frame. Let's say we want it to be 500 pixels by 500 pixels. And then that we want to use. Usually the most common one is cv2.enter area. Enter is short for interpolation and just using the area. There are other types. You can see cubic, linear, and so on. You can try them all. But the most common one is the enter area. Yeah, and that's it. Now this frame that is read from the video is resized to 500 by 500. This is a tuple, by the way. We're passing a tuple. And then we show this frame. So now it should be bigger. Huge cat now. Okay. Another thing that I want to demonstrate is the effect of this wait key. Right now, you might see that the cat is a bit too quick, but this is because we are just having 1 millisecond between each one. So if you can increase this delay to maybe 5 seconds, 5 milliseconds, then it should be slower. You can notice if you do like 50 or something, it'll be slow motion. Okay. Okay, it's not opening. I can't get it to work. Okay. Is it showing any error? No. Then if it's just running and then not showing any error, then you might need to open folder and select the exact folder that you have the Python script inside. Then try running again. Nice. Is it okay so far? You have to press Q many times until the video closes. Explain the code one more time. Yeah, sure. For the pressing Q times, I'm not sure. It should be like immediately, as soon as you can try keep pressing for like at least 1 second, then it will close. Because it's checking every 1 millisecond, unless you have this to like a very high delay. Or if you have it to 0, then you have to press for each frame until it closes. Make sure it's 1. And then make sure there is break, because the break is the thing that breaks the while loop. If you don't have this, then we'll just exit 1 frame. Okay, I will explain the whole code one more time. The first thing we do is import the library, which is CV2. This is the OpenCV Python library that I had you install. And the first thing we do is define a video capture using the video that we want to read. This is a class, a video capture class. And this is the initialization function that it has. And this is the object, the new object that we create. And this object has a is open method inside. So we're saying while it is open, while there are frames to read, then we're going to do these operations. So the first thing we're doing is reading a frame, 1 frame of the video. And then we're getting 2 things. We're getting a return. It doesn't do something. It just creates this object. It's a class. You remember yesterday when we were like person? Person something something. Video capture is the same. It's a class. And then we're initializing this class with the video that we want to read. Okay. So after we have the frame, we read the frame, and we get the return. The return is true or false, whether there is something to read or no. Successfully read something. And then we're just resizing the frame. So we can change this. It doesn't have to be the same frame. We're just assigning it to the same frame. We can have it as a different name, maybe resized, to like keep the original frame the same intact. Or we can also override the original frame by resizing. Depends on what you want to do. And we're resizing this frame to this size. 500 pixels by 500 pixels. Okay. How do we comment part of the code? You can highlight it and then press Control and / on the keyboard. This. Comments and uncomments. Or you can manually add or remove the hashtag. Okay. The video is so fast because of the time that we're waiting. We're waiting for only 1 millisecond between the frames. And the original video might have been maybe, let's say, 15 frames per second. So we're like fast forwarding through the video. You can set it to something around 20, maybe, then it won't be this fast. Be okay. And you can even slow it down if you increase it to like maybe 50, be like slow motion. Okay. The cap.read reads 1 frame of the video, reads the next frame of the video. So reads 1 frame, and then we call it again, reads the second frame, and so on. And we need return because this is returning 2 things. Returning the return, whether it's successful or not, and returning the frame itself. Okay, wait. Why do we need return? Because we might need to check if we successfully read something, actually read a frame, before we do something here to see, like, we can check if it equals true. So equals true to check that, yes, we have actually read something before we do any of the frame operations. In case our video is not stable, in case this is connected to an actual webcam that might get damaged and so on. But for now, we're not using it for anything. Okay. Interpolation is like moving between 2 points, like filling the gaps between 2 points. So if you have an X, let's say an X point and another X point, and you want to connect them or add points in between them, so you'll be interpolating between these 2 points. And what this does to resize the frame is takes each pixel of the frame and then interpolates the surrounding pixels, and then you get a bigger video. And there are like different ways to interpolate using the area around the pixel. There's cubic interpolation, linear interpolation, and so on. Okay. When I ran the code, I got exited with code 0 and 0.32 seconds. Is there any other error other than exited? If not, then you might need to go to File, Open Folder, and select the actual folder that has your code inside. For some reason, my library is not recognized anymore after I changed some stuff in the directory. I returned it back to how it was, but it's still bad. SMH. I'm not sure what you changed exactly, but you can try uninstalling, like pip uninstall OpenCV Python, and then installing it again. Maybe it fixes the issue. What if we need to make it smaller? You can make it smaller. Let's see first what are the current dimensions of this frame. So we can do this by dimensions equal frame dot shape. So this dot shape returns the width and the height. Oh, okay, just below the VS Code. Nice. So this shape returns the width and the height, and then the type with a RGB and all the stuff inside. So all we need is the width and the height to see what is the current width and height. So let's maybe print dimensions. It will keep printing multiple times, but that's okay. Okay, these are the current dimensions. 154, 174, and then 3 is the RGB channels. Or actually for OpenCV, it uses BGR, no, the regular RGB. But these are the current values. So if you want to make them smaller, you can just do smaller values, like 80, for example. Then it's be a very tiny box. Okay. Any more questions regarding this? Okay. If no questions, the next thing we're gonna do is draw stuff on this video or images in general. So the first thing we're gonna do is align. So there's a function called cv2.line, and this draws a line on this image. So the first thing we're gonna pass is the frame that we want to draw on, and then the first point, that's line. So let's say we want to draw a line across the image diagonally. So we'll start at 0, 0. And then the line ends at 499, 499. Okay, since the size is 500, That means 0 to 499. And then we need to choose the color. And as I mentioned, it is PGR, not RGB. So if we want to make it blue, which is P, which is the blue part, it will be 25500. Okay. 255 for the blue, which is the max value for the blue. Green is 0, red is 0. So this will be a blue line. The next thing we want to do is the thickness in pixels. So let's say 3 pixels should be enough. We also have line type and shift, but these are optional, so there's no need to add these for now. And what this should do is just draw a line diagonally from the top left to the bottom right of the frame for each frame. So let's see. You can see this blue line across the frame. You can play around with the points, set whatever points you want, change the color to something else, change the thickness. We can make the line 20 pixels thick. Let's see. And let's not make it very slow motion. Like a very thick line going across. Okay. Can change the color to, let's say, purple, which is full blue for red. Okay. Yeah.
I'm sorry, I have a question. So for this
Sure.
line function, if we like want to skip such an argument, because like line have a lot of argument that you have to enter, like the thickness and color and stuff. So what we if we like want to skip like an argument,
Mm.
is it like even possible like skip such an argument and just enter?
Yeah, it depends on the argument itself. Some are required and some have default values, so you don't need to enter. Like line type and shift are optional. You don't need to enter them, so we didn't enter them. For the thickness and the color, I think they are required. I'm not sure, but let me check. So if in case anyone needs to check these functions at any time, this is the official OpenCV documentation, OpenCV Python documentation. And we're currently drawing. So I think it's inside this one. Oh no, I think it's GI features. Okay. Drawing functions in OpenCV. And for the line, it's somewhere here. Polygon ellipse line. Yeah, this is the line. And if you press on this function, it like gets you the definition of the function. These are the arguments, what you should type inside them, and so on. And I'm not sure how to check whether they are required or not, but I think you can try to run directly. Let's say I don't want to specify thickness. Will this run? Yeah, it still runs with the default value of one pixel. And let's say I don't want to define the color. Okay, the color is required. There's an error. So yeah, I think this is the minimum you can do. You need at least 2 points and the color. And the thickness will then default to 1 pixel. But yeah. Any other questions? Can we apply the same code to the image? Yeah, sure. It's the same exact code. Let's take this, comment this, put this here, uncomment the image parts, name this to image, and it works the same. But the line won't be until the end of the image. I'm not sure of the dimensions of this image, but let's see what it does. Apparently, yeah, it just draws a line from here to here. Can find the dimensions of this one also. Dimensions equals image.shape. Print these dimensions. So it's 100 by 689. So if you want, we will do something like this to 999, then 687. Oh, it's the other way around. 687, 999. 7, 999. Okay. It draws it to the end of the image. But yeah, it's basically the same code. Any function that we'll use for the video can run on the image also. The X and Y thing again? Yeah, sure. I mean the dimensions, right? The dimensions you can get from any frame or any image by just saying the shape, and then these are the dimensions, the output. So this is the height, and this is the width, and then this is the shape of the RGB spectrum, which is 3, 1 for R, 1 for G, 1 for B, and so on. Yeah, we use the while loop because it's a video, and we want to like do operations on every single frame of this video. So we're like looping through each frame inside the video. So we turn this to here and comment these. Oh. Okay. Okay. Any other questions? Okay. If no questions, then we're gonna draw the next shape, which is a rectangle. So the function is cv2.rectangle, and it's gonna have the same, almost the same arguments. We need a frame, and then we need the point, the top left corner of the rectangle. And so let's say just any random point, 100 by 100. And then we need the second point, that this rectangle, the bottom right point of this rectangle, which let's say is 400 by 400. Then the color, let's say 25500, thickness of 3 pixels. These are the same arguments for the line, but instead of drawing a line between these 2 points, these 2 points will be the top left of the video of the rectangle and the bottom right of the rectangle. Okay, so this is a rectangle, or more like a square now, since we gave equal sides. But this is how you draw a rectangle on OpenCV. Of course, we can change this to green, the classic like object detection color is green always. Okay. Any questions about this? Okay. If no questions, the next thing we're gonna draw is a circle. So it's the same, cv2.circle. We're passing the frame, but this time we're only passing 1 point. This point is the center of the circle. So let's say we want the circle to be at the middle, 250 by 250. And then we want the radius of the circle in pixels, of course. So let's say 30 pixels. The color 50. Then the thickness 3 pixels. Almost the same, just that this has a radius instead of another point. Then we get a circle. Okay. Can increase the radius maybe to 100. Bigger circle. Okay. Any question regarding this, regarding circles? Okay. Finally, we want to put text. So the function is called cv2 dot put text. And then we'll define the frame. And then the text that we want to put. For this, let's like make it a meme. It's like me when I get an A. Okay. And then this is the origin point of this text. So it's like the top left of this text. So this would be the point, and then the text would be underneath the point, like this. So let's just define, I think 40 by 40 should be fine. Still will be at the top, but like a little bit down. And then the font face. This is usually cv2 dot, and then you will find multiple fonts here. The one that is usually used is called font Hershey complex. Okay. Then this is the font scale, which is essentially the size of the text. So let's set this to like 10 pixels for now, and let's see if this makes sense. And the text, let's make it this time completely black. So 0, 0, 0. Then the thickness of 3 pixels. See that the text takes a little bit more arguments because you have the font, the size of the text, and so on, and the text itself. And usually it's going to be like this, if not more. Okay. So let's see what this looks like. Okay, this is very big. Let's reduce this to, let's say 2. Okay, even 2 is still big. 1 should be enough. Okay. Me when I get an A. Very accurate. It looks a little bit too thick. Maybe 2 pixels thickness should be enough. Yeah, okay, this looks clear. So this is how you add text to an image. And usually you would be like, let's say adding the next to a detection or something. Kind of file here so we can follow, please. Yeah, sure. I can send this. Let me send this right now. Yeah, we're using a while loop because we're reading you as a whole and then applying something to it. We're applying something to each frame of the video. We receive one image of this video, one frame. We do some operations on this frame, and then we show it. And then 1 millisecond later or 20 milliseconds later, in this case, we get another frame, and then we keep doing this. CV2, the I'm show, it just shows the image. If you don't want to see the image, you can just comment these two, or just comment this, because this still delays 20 milliseconds, which is necessary. Otherwise, you're gonna see the video in like nanoseconds, and then it's gonna close. Yeah, if it's an image, we won't use while. If it's an image, it will be just these. This is optional. This is not required. It will just be this line, read the image, display it, we're done. If you want to do any operation, you do it here before displaying the image. Okay, let's run the current OpenCV.py. Any other questions? Right, frame doesn't refer to the window that I've opened. It refers to the frame that I've read from the video. So this doesn't display anything, and this doesn't display anything. None of this displays anything. Only I'm show displays something. This just gets the frame from the video, but doesn't show anything. We just have the frame as an array. It's actually like 3-dimensional array, and then the pixels for X, the pixels for Y, and then the RGB value for each one of them. It's not really an image, it's like an array, a multi-dimensional array. And then we do some operations on this array, then we show this image here. Read is short for return, and it's meant to be like, did we read successfully or not? So is this return successful? You can rename this to anything actually, but return is a taken word because it's used inside function. You can, let's say, name it success. Success frame equals cap read. As long as you know that this cap read returns two things, returns whether it's successful or not, and then returns the frame, the actual frame. Okay. Shouldn't image show should be before the text, or it doesn't matter who's first? It matters who's first. If you put this before the text, then you won't get the text on the image because you're showing the image before you apply the text. So if I run this, I'll just get the normal video without the text because I'm showing the frame and then I put the text. But what we want to do is put the text on the frame and then show it. This way we have the text on the frame when we show it. Okay. Any other questions? Yeah, we didn't define this before. And this is the beauty of Python. You don't need to define anything before. As long as you say something is equal to something, Python automatically knows that this is a Boolean or this is an integer or a float, or doesn't matter. And say x equals something, x equals 7, and it knows that this is an integer. Yeah, frame isn't a Boolean. Frame is an array. Why are we showing an image on line 22 if you've already done the video capture for the cat and before? This also doesn't show the image. This is just gets the reference to the video. And it doesn't even get the whole video, just stores that there is a video at this address, at this cat.mp4. And then when we do cap.read, it gets the first frame of this video. And then we do some operations and then we show this frame. And then we get the second frame and so on. This is just where it can find the video, but it doesn't actually do anything. But if I comment all of this, it won't do anything. It'll just, okay, done. Okay, explain one more time. Sure. So overall, what we're doing is just importing the library, the CV2 library, and then we're setting that this capture object is of this class, video capture class, and we pass the address to the video that we want to read, or we can pass an integer let's say 1 or 0. And this is gonna open the webcam. If you want to do something on your webcam, the webcam video feed, then you can type 0. I cannot show you now because I am using the webcam now. So it will say that it cannot open the webcam. But you can try on your own laptop. If you type 0, it should work. It should display the video feed from your webcam. Okay. And then while this is open is just a check if we successfully got the video, it's in this address and it has frames. This video still has frames. While this is true, we're going to read this frame, read one frame, get whether this was a successful read or not, and the actual frame that we read. And then we're gonna resize this frame to 500 by 500. And then we will add the text on top of this frame. So now we have a frame, and then we resized it, and then we put the text, and then finally we'll show the frame. Okay. We'll show the frame. Then the final thing is just waiting. If there is any key pressed, if you do press a key, it will break. All these numbers are just formatting. Yeah, all these are just formatting. This is the position of the text. And this is the font that you want to use. This is the scale of the text, how big the text is. This is the color of the text, and then the thickness. For the webcam, it doesn't ask for permission, it just uses it. Q just refers to the letter Q on your keyboard. Yeah, you can say quit. You can put any letter actually, it doesn't matter as long as it quits when you press this letter. E, S, whatever. It's just the standard to use Q. Most of the people use Q. Yeah, I guess it stands for quit. Okay. And this ort function is just returns the Unicode of one character string. So it returns the Unicode of Q, because this wait key function also returns a Unicode. So it just compares if this Unicode that we got from wait key is equal to the Unicode for Q, for the letter Q, then we break. Ret is Boolean, a frame is an how, are both different types, and they're actually the same thing. Because it's not one object, it returns a tuple. Cap.read returns a tuple. It's like you define a frame, a function. Let's say function example. Okay. And this function returns two things in a tuple. Returns, let's say true, and a number 32. It's okay, it can return these two. And then we're just setting these two to two different types. We can say just get one of them. Like we can say total return or something. You can convert this to ret. And then we'll have to do like ret 1 for the frame and ret 0 for the successful or not successful. But it's just easier to put it in two variables so that you can change easily. You can use both of them easily. Why is changing the input to wait key changing the frame speed? Because this is the amount of time that you wait. So if you wait between each frame a certain amount, then you're changing the speed of the video playing. If you wait 1 millisecond between each frame, then the frames per second of this video is higher, depending on your processing power. And if you say so, then you've decreased the frames per second for the video. So instead of doing, let's say, it would have been able to do 60 frames per second, but then you made it wait. So now it's doing 30 frames per second and so on, something like this. Okay. Any other questions? 1 millisecond was bad. It depends on what your priority is. Is your priority processing the frames faster or exiting faster? Or usually you want the fastest processing power possible. So you can set this to 1 or something. Implementing threading multiple threads. So it's not actually waiting in this thread, so the processing can continue. And then it's just displaying in another thread. The IM show is in another thread and the waiting is in another thread. If you want the maximum performance. And then I don't press on Q. Once the video is done, it will just exit automatically. Okay, this is a bit, yeah. Okay, the video is a bit long, but you get the idea. Yeah, I cannot, but I cannot run it because I'm already using the webcam. So two programs cannot use the webcam at the same time. But the idea is just you put 0. That's it. That's all. Put 0, same code, same everything you run. It should work. You should add text on top of your webcam feed. Same if the webcam is not built in, just an external. Yeah, the index is based on the number. So if you have one built-in one, so this will be the 0, and then you connect another one. It will be external one will be 0, and so on. It just depends, plug them in. Okay. Any other question? The next topic is color detection. Okay. So for color detection, we'll change the video to this random guy juggling. I don't think we'll need resizing for this. And let's change this to, let's say, juggle. Okay. I'll show you the video first. The video of this guy juggling. Okay, it's way too fast. Let's say 20. Okay, 20 is slow, but you get the idea. Let's say we want to detect just the red balls. We want to remove everything else on the screen and detect the red balls only. 10 is okay. Okay, yeah, 10 is nice. This guy to do is change the theme. Oh, of this. HSV stands for hue, saturation, and value. And I'll tell you why. And then another one that we have is BGR, and then we're going to color BGR to HSV changing. The do this is that it's very difficult to get a specific color to like move closer to some people directly, and we want something to work depending on the color only, not the light source. Two values. Hue is the actual color. Saturation is like how bright or dark it is, how bright the color is or dark. Using HSV, we can like accurately determine the color that we want, and I'll show you how in a second. Okay, use something for the HSV. And and we usually want like on so we have 350 for the bright areas, and if we go to the dark areas of the ball, we have like 342. Okay, so the range that we have is approximately 340 to like 350. Maybe if we get somewhere that is really okay, 345 still. 350. Okay, so 340 to 350 approximately. If we go back to our code, let's set this 340, and this one is 350. Okay, this is the values you want to start with, 100 and 255, and then we'll edit these values depending on the output. Let's try this for now. The next thing we need to do is get a mask depending on these ranges. So mask will be equal to cvd.inRange, function called inRange. We'll pass the HSV frame that we got, and then we'll pass the lower bounds and the upper bounds. Okay, that's all we need to do. Now we have a mask. And let's see what this mask's output is currently. So if we run this again, see that we cannot see none of them. So maybe the values for the saturation or the value are too high or too low, and maybe the hue itself might not be accurate. So let's check. Oh, and also something else that I forgot is that OpenCV has the hue value between 0 and 180, not between 0 and 360. If you check back this website, it has the maxima at 360 with saturation and value at 100 and 100. So 100% for OpenCV would be 255, and 360 for OpenCV would be actually 180. So we need to divide this by 2 and divide this by 2. Now it should work. Okay, so now we get a basic view. You can see that the guy is actually a bit red also. So that's why it's detecting part of his lips, maybe his collarbones. So we can fix this using the saturation and value. Let's set this to maybe 120 for the saturation and value. Parts of the guy should disappear. Okay. Only left with his lips now. Let's increase it more. 140 maybe. Okay. So now we're getting mostly only the balls. And what we can do is also increase this range a bit. The standard is to -5 and then add 5 here also. So like plus -5. Then yeah, can get just the balls, just the red balls in the entire frame. So if like specifically detected the red balls. We've removed everything else from the image. This is the mask. And this is now colorless. The mask is colorless. So let's add the color by saying that frame, or let's say result is equal to cv2 dot bitwise and. So what this does is it takes the mask and then applies it to the image, and then stores it in the result. So we're gonna say frame, which is the original RGB image, frame, the mask equals mask. So this applies the mask that we've obtained that only has the red color balls, and then it applies it to the original frame that we got that still has the whole image, and it does bitwise and. So the parts that are black, which are 0, will totally remove any other color. So we get everything else is black, and then the balls will be the original color. So let's display this result. We should have just the red balls moving. Okay. I know this is a bit too much, so does anyone have any questions? The background of the window from black. You can theoretically do this while the mask is applied. You can do this, but it's better to do this after the mask. Like after you bitwise and you have the result. If you want to like change every pixel that is equal to 0 to something else, you can do this, but it will just be a for loop and you'll check if the value is 0. Can you repeat the last step, which is adding this bitwise and? Bitwise and is just you take the frame, which is the original image that we didn't modify, didn't do anything. We just used it to get the HSV frame, and that's it. So this frame still has all the color, all the like features, the balls, everything. So we take this frame, then we apply this mask that we got. This mask is just the red color balls. Everything else is black. Only the red color balls are white, right? So if we do bitwise and with this mask, so what it does is compares every pixel and then it ends them together. If the pixel is 0 there, if it's black in the mask, then it will just become all 0 in the actual image also. If the image is white at this part or 255, then it will let all the color pass this mask. This is what bitwise and does. So what you get at the end is just the colored balls, the red colored balls of the frame, which are these. Okay. Okay. The video you sent seems like the balls are not clear. You can try doing the process that I just did on the website to get the values. Maybe it's a bit different on your PC, but the code cannot see clearly, but seems okay. Twice and HSV lower bounds. Yeah. So maybe try getting the values again. Nice. How do we get the values again? Yeah, the lower and upper bounds. You get them by screenshotting or taking one frame of the video and then going to any online color picker or color chooser. And then you get the HSV values. The hue is here. You start usually the saturation and the value with 100 for the lower bounds and 255 for the higher bounds, for the upper bounds. And then you just get the hue value. But be careful that it's divide 2 because the maximum for OpenCV is 180, not 360 in case of this website. So I have to divide by 2. Yeah, other than that, you just click on the pixels, get the value of the hue for the lower bounds and for the upper bounds, for the dark areas and for the bright areas. And then you just plug them in the code. And if you want to like filter more, you can use the saturation and value to change them. Okay. Any other questions? Yeah. Can we put a square on the apple, same as the live detection? A square on the apple. Oh, you mean detect that this is a circle, this is a thing, and then draw a rectangle around it? You can do. This is what we will do next, detecting circles. Can you change the background color to not be black? You can do this. You'll have to write a for loop to check if this pixel is black or not. And if it's black, give it this color. But it's unnecessary for most applications. If you're using OpenCV, you want the thing to run as fast as possible. You don't care what the background color is. If you're doing a robotic arm that has to see something on the assembly line, for example, you don't care what the background color is. You just care where the object is. Okay. What do I what do I do after I get the values? These are RGB values. Make sure to change the values to HSV, hue, saturation, and value, not the RGB values. Hue, saturation values. And then we just want the hue. Okay. Hue is 0. It can be sometimes if you're detecting something like near white, but usually it shouldn't be 0. The blue seems to be around 200, while red is around 300, and green I assume would be around 100. Not sure how you got 0. I sure it's here, and the hue value is 0. Are you using the same website? I can send this link on the WhatsApp group. Then you can try using the same link. Okay. Any other question? Yeah, you can add the text tag. You'll just change the frame to resolve here, and then should be fine. Okay, the color is black. Let's change this to like 5. Me when I get any 2 balls for some reason. But yeah, you can add any of the previous circles, rectangles, and lines, and so on. Just be sure to select the frame as the resulting frame. Okay. Okay. Yeah, you can do this, but it will require you to detect that this is a ball because all the computer sees for now is just a bunch of pixels that after applying the mask. So the next thing that we will do is get the circles, detected the circle, and yeah, if it's a near circle, we can change the how confident we are that this is a circle. And then once we detect the circle, you can get these pixel informations. Then you can draw whatever you want or add text wherever you want. So the next step is circle detection. Okay. So let's say circles is equal to CV2 dot is called half circles. Okay. But before we do this, we need to have a grayscale image, not just the normal image, because the half circles function requires a gray image. So let's say resolve gray is equal to CV2 dot convert color, and then CV2 dot color, and then we want BGR to gray. I'll just type color BGR to gray. This one. So the first step is converting this results to a gray image. Pass this to half circles. Okay. The second thing we have is the method. Okay. And the methods that are available are type first half, gradient, alt, multiscale, half probabilistic, half standard. Usually everyone uses half gradient. You can try the other methods if you want, but the standard is half gradient. Okay. Second one is the third one is dB. dB is like the resolution of the image that you're going to enter to this circle detector. So if you set it to 1, it's just the same resolution. You can say 2, and it's like half the resolution. So let's say 2. Okay. And then you have minimum distance. This is the minimum distance between the centers of 2 circles for it to be like successfully detected. So we don't want them to be like 100 circles overlapping each other. So we need to set the minimum distance between these circles. So let's say 50 pixels. Okay. And we can skip this one and jump straight to parameters 1. So there are 2 parameters. This parameter 1 controls like the edge detection. So the way this works is it takes the gray image, it detects the edges first, and then it tries to detect the circles. So this parameter 1 is the detection like the canny edge detection, you specify the threshold for the gradient to be either detected as an edge or not detected as an edge. Okay, the gradient is like the slope. You don't need to really understand it. Just notice that if you increase this, it will be less edges because it will be harder to be an edge if the threshold is higher. Okay. And then there's the second parameter. This one is like how confident you are that this is a circle. So you can set this if you increase the value. Let's say you begin as 20 and you don't see any circles. So you decrease this value. And let's say you begin at 20 and you see like a lot of circles and stuff that doesn't look like circles. You need to increase this threshold and then it will only show that stuff that is relatively sure that it's a circle. Okay. So this will give you the like list of circles, but let's transform this to a list first. So circles equals circles dot to list, just for us to be able to view these circles and add circles. And then, but before we do this, let's make sure that there is circles by saying if circles is not none. If we actually detected something first, then we do this. We put it to a list, and then we say for circle in circles 0. For some reason, there is an like this list has only one component, and then it contains all the circles. Don't ask me why. They wrote the library. Okay, and what we're gonna do now is cv2.circle, the same function that we used, and we're gonna draw a circle on result. Okay, the center point is going to be this circle 0 and circle 1. And this is a float at the moment, so you need to cast it to an integer because pixels are integers, they're not floats. Okay, so this is the tuple, the x and y position. And then the radius is the last one, should be in circle but 2. So this returns for every circle, it returns the x and y position, which is 0 and 1. And then the radius is the 2, index as 2. Okay. Then we have the color. Let's make it the standard detection color, green. And then thickness, let's say 3 pixels. It's based on toList after we make them as an array. Yeah, it's based on toList. For this one, it's almost the same, circles 0. I can print if I show you the circles, but this will print so many circles. So let's break straight afterwards. Okay. I'll just show you like what the circle matrix looks like. Okay, something is missing here. CV2. Oh yeah. This is missing the frame itself. That is all the frame. Okay. So this is what it looks like. This is the circles array. It has one outer array that contains nothing but an inner array for some reason, which is the circle 0 that we have. And then this inner array has 2 arrays, one for each circle. This is the first circle, this is the second circle that we detect. And then this is the pixel value for x, for y, and then this is the radius, then x and y, and the radius. Okay? So we're saying for every circle in this second array, which is the first array 0, index 0, for every circle there is, for every array, this is 1 circle, this is 2 circle. We will draw a circle at the x and y position with this radius. Okay. comment this, comment this. Okay. So this should, if there are any circles, this should draw the circle. Let's see if this works. Okay, it detects the circles, but you can see like some phantom big circles. So to fix this, we need to add a max radius parameter. We don't want these very big phantom circles to appear. So let's say the maximum radius that a circle can be is, like, say, 40 pixels. Okay. So now if you run, just get these two circles that we have detected. We have highlighted these two circles. We can get the X and Y position at any time using this function. You can draw this circle. If you want to draw like a rectangle based on this X and Y, certain size rectangle, that is possible. If you want to put text using this X and Y coordinate, it's also possible. As long as you have this array with the X and Y coordinate of the circle, you can do whatever you want. You can use the radius maybe to determine the size of the rectangle. You can use this maybe to like how high the text you'll put will be, and so on. But the most important part is detecting that there are circles first, which is this function, the half circles function. Okay. Any questions? I think this might be like too much to digest at once. The loop shows the coordinate. This one doesn't, but you can print if you want. You can print the circle X and circle Y. This one. This would print the two circles for every frame. A lot of circles. This is the XY coordinates for every circle. Can send the juggling video. I already sent it's inside the OpenCV zip folder that I sent previously. What does the PGR to gray do? No, this is not the red color. This is converting this image, the result image, to a grayscale image. So let me show you result gray. Result gray is just the same image but like in gray. The same frames but in gray. Because the half circles, the function, this function, requires a grayscale image to detect the circles. So you just like get one frame, like transform it to a gray frame, then pass it to the half circles. Okay. Can't get it to work. Why? Is there any error, or maybe the values for this are not the same? I tuned this beforehand, just so you know. It's not usually like you just run it and then you get two circles. But you need to keep running. You need to keep changing the parameters and then seeing how if you try to decrease this, like this is 30 now. If I decrease this, which means like allow more stuff that don't look like circles, you'll like find okay. Okay, wait, we're not showing correct frame result. Might get like a sea of false circles around the thing. This isn't giving that we already have this max radius. If we don't like it, sorry. This is a form of art. Okay. So these parameters are very important. If you find too many circles like just now, increase parameter 2. We'll make sure that this is like an actual circle. And you can put this max radius because often the false circles are very big and so on. Okay. Say to required argument. Oh yeah, this is here. Add this result to this line of code. For Ahmed Muhammad, add result here. So this loop, so the program is traced with the circle coordinate in order to detect it, but we don't need to print it. Yeah, we don't need to print it, but it's just for like going through each circle and drawing the green circle around it using the coordinates of the circle. We already get all the coordinates once we detect here. We were just looping through this to like put circles on it. Okay. Any other questions? So this only detects 2 circles? No, this detects as many circles as there are in the image. Just happens that we have 2 circles now. Yeah, any number. But now it just returns 2 because there's only 2. Previously, if I said this, if I change these parameters like to 20, and then it detects also the false circles that yeah, can detect as many circles as possible within the image. Okay, there's a next segment parameter. Parameter 1 is an invalid. Okay, for parameter 1 and 2, change the E to an A for Abdullah. This should be an A, not an E. PARAM 1. Same for 2 also. The if statement is just to make sure that there is a detection. Because if I try to do something using circles, but it didn't return any circles, 0 circles, then it will give me an error. It will stop the code. So at first I'm checking if there are circles. If I detected any circles, then do this, like display all the circles, throw circles around them. But if there are no circles detected within this frame, so like don't do any. Don't go inside this unless there are circles detected. Okay. The code, okay. I'll send the new OpenCV. Okay. Okay. If there are no questions, then the last thing I want to show is the line detection. So for this, we'll be using the last video. We change this to road.mp4. And basically what we want to do, no, sorry, we're finding and drawing circles using CV2 half circles functions. Then what's the episode? Oh, no, the CV2 half circles function doesn't draw anything. It just detects where the circles are and then returns like the XY position and the radius. It doesn't draw anything. And then this if condition is just using this X and Y, these X and Y coordinates to draw the circle around it. Okay. Okay. Okay, so we'll be using this road MP4. Let's comment all this. Let me show you just the frame itself. So this is like a driving POV. And what I want to do now is detect these lines as if we're like trying to do an automated car that detects like the lanes and then tries to center itself. Okay. So same as the half circles, we need the image to be in gray. So let me just copy this. I'll put it around here. Let's say frame gray. That's frame. So we have the frame in gray. Now we can run the lines detection. So it'd be like lines is equal to CV2 dot, and then half lines. There's lines and lines B. Lines B is better at detecting lines. Oh, okay, 15 minutes break. Okay, sure. Let's take a 15-minute break and then we'll be back. We'll continue at 12:05 in Malaysia time. I don't know what's that in whatever country you are. If you guys don't mind staying for some overtime for the last thing, I'll just do the lines and then that's all. So if you want to go pray, we'll pause for a bit and then we'll continue at 12:05. Also, you need to like take the attendance. They've sent the link inside the chat box. So fill your attendance. what I'm saying? Okay. Okay, so the lines got comment. Okay. So this is the output of the canny edge detector. You can see it's the video, but it's just the edges of everything. Okay. So we can try increasing this, like maybe 200, and this is 100. And say like it's less edges compared to just now. And you can keep playing with this, but for this application, it's fine. And one more thing we want to do, since we're focusing on just the road, nothing else, so we can exclude from our detection all these trees that might like be detected as lines in between. So maybe we'll just cut the screen at the middle part so it can be easier for the algorithm to detect. So the way we can do this is by defining the ranges for this edges frame. And this video is 1 to 80 by 720. So let's say we want these the bottom half of the screen, so like 360 to 720 or to 719, since we're starting from 0. Okay, this is the first part of the array. And then the second part would be 1 to 80 until like we need the whole screen, right? So just 0 to 1 to 79. So what we have now is just the screen, but then it's cut to half of its height. So we like crop the screen. So now we can just focus on the row. And I think we need just a bit more just to ensure. Like let's start it at like 400, let's say. Yeah, so we can just see the road, maybe even 450 or 430. 420 should be fine. So yeah, we just see the road. We don't need any of the trees. So we can detect these two lines with high accuracy. Okay. So once we have these edges and everything, we can do the half lines function. And we're going to pass the edges that we have. The second thing is row. Row is the resolution for the distance of the lines. So usually you just keep this at 1 pixel. You don't need more. And then theta is the resolution for the angle of the line. And usually you want this to be a very small value, let's say 0.01. It's in radians, not in degrees. Okay. And then this is the threshold, the first threshold for the line. And this is what like controls the detection of the line, how good the line detection is. Let's say 60 for now. Okay. And then you can skip the rest, and the relevant ones are the minimum line length and the max line gap. Okay. So the minimum line length is the minimum length that a line can be for it to be considered a line. If you have a line that is too short, then they won't include it in the detection. And since we want to like measure like a very long line, so let's set this to like 300. Okay. And then for the max line gap, this is the max gap between 2 points to still be considered within the same line. And we want this to be like close to 50 pixels. You can try reducing this and seeing the effect and increasing it. But for now, this should be fine. So yeah, we have our line detector, and we do the same thing as we did in the circles for lines that we got. We first will have the x and y position coordinates. So x1, y1, x2, y2 is equal to lines 0, outline 0. Okay. So all of these are in one array, which is inside the line 0. Okay. And then we need to draw this line to the line. Let's draw it on the original frame. Point 1 will be x1 and y1. And then point 2 will be x2 and y2. The color, let's make it green. 5, 0. And the thickness, maybe 2 pixels. That's all. That's all we have to define. And then let's display frame instead. Okay. That's all we need. You can also add the check here, just to check that if lines is not none, if we actually have a detection, then do all this. Otherwise, don't bother. Yeah, that should be all. Let's run this and see the output. Okay, we noticed that the lines are drawn, but like they're not in the correct spot because we cropped down the video. So for every Y, we need to add in the amount that we crop. So we crop like 420. So let's add 420. Let's add 420. So now we can see the lines are detected in the correct spot. It's detecting like the lanes, the left and the right lane. Seems like the lines sometimes disconnect. So maybe we want to decrease this line threshold, let's say 55. Yeah, this line seems like it's kind of disconnecting. This line is very nice. And once this catches on, it also becomes very nice. So you can see like there was some noise at the middle just now. And now, yeah, some noise. You can solve this by like maybe decreasing the frame a bit more, cropping the image a bit more, so we don't include the trees. It's 450, 50. So now we stop at here, but at least we don't include random tree detections. And we can play around with the minimum lines and so on. Let's set this to 200, maybe. So now you can get more lines on the right side because it was disconnected at the beginning. And then yeah, you get a good detection for the lanes. You can try to decrease this even more, 150. Have more consistent detections on the right side at the beginning. And yeah, so this is the line detection in a nutshell. You just need to, oh, just now it displayed some, and you can even check for if you like receive these X and Y coordinates, you can maybe check for the angle of the line to see if it's like horizontal line. We don't need that. We just need the lines that are in this angle. You can play around with these values. Make sure it's aligned more here. The minimum distance to be aligned, the max gap between 2 points to be considered aligned, and so on. So yeah. Any questions about the line detection? This is the last module. If no questions, then we can end. Okay, before we end, I just want to show that OpenCV still has lots of functions that we've not explored, and I just want to highlight some of them. So if you go back to the OpenCV Python tutorials website, I will send this also on the group. These are all the list of all features. We did some of the image processing in OpenCV here. We did like canny edge detection, half line, half circle transform. We did some smoothing. We did changing to other colors, changing color spaces, and so on. We even have the isolation here, the detection for the color. And something that I want to highlight is template matching. It might be like the closest thing to object detection that OpenCV had. And it's just you use one image and then OpenCV tries to see if there's like this image is included in this image all over image. Like you get one coin, an image of one coin, and then it goes around the image trying to detect if there is this coin picture. So you might try this. It's much faster than regular object detection since it's just moving around the image and then comparing, oh, is this the same pixels or no? So yeah, there are